interference. Okay, you've got your vintage radio, your valve radio. Interference can get into the radio basically in two ways. Either down your aerial, okay, you've got your aerial outside up in the garden, interference can come into the radio that way along with the radio stations that you want, or it can come down the mains lead, okay, into your radio. Now your house wiring, or like all the electrical wiring in the workshop here, will act as an aerial. Any piece of wire, this wire from my test equipment, even though this is only a couple of feet, a yard or so long, it's an aerial. It will pick up radio stations. Any metal, the metal angle poise lamp, that is acting as an aerial, albeit a pretty poor one. So your house wiring, bear in mind it goes up in the loft and round the walls and under the floor, that's acting as quite a good aerial. So when the mains comes into your radio, okay, not only is the 230 volt mains coming in, but radio stations are coming in the form of RF. So you've got to stop that. How do you stop you want to keep the mains coming in, obviously, otherwise the radio won't work. Duh. I was actually, you could unplug it, that'll stop it. But anyway, or somehow block the RF that's coming into the mains, down the mains lead into your radio. Now, what most manufacturers did in the early days was stick a capacitor directly across the mains. In a lot of the radios, it's on the back of the on-off switch. There's a capacitor. That's the one that blows up after a few decades. But a capacitor, okay, to RF looks like a little bit, this is very simplified obviously, it looks like a short circuit. So RF comes down the mains, hits the capacitor and is just taken back, say, to the neutral. It's shorted out so it doesn't go any further into the radio. That's what most manufacturers did. Some went a little bit further. Have a look at this diagram. This is actually a Bush DAC41, I think I got this from. You see where the mains comes in, the live and the neutral both go through RF chokes. Now an RF choke, as the name implies, it chokes off RF. It won't let RF through. Now bear in mind, RF signals, that is what's coming down the mains, radio stations that the mains wiring is picking up as an aerial. We want to get rid of that RF. So a couple of chokes won't allow the RF through. And then what they also do is stick a capacitor after the RF chokes. So any RF left will then be short-circuited by the capacitor anyway. Okay, so that's quite a good way of doing it. Just going back to RF chokes, have a look at this diagram here. This is a transmitter. That's what they call the PA, the power amplifier. On the anode of the valve, you've got DC. Okay, it might be 2,000 or 3,000 volts in a large transmitter. You take off the anode, the RF. You might have 100 watts of RF. This is your radio station you're transmitting. 100 watts. Okay, that comes out of the anode. Now that RF, that 100 watts of RF, you don't want going back up the HT supply, to the power supply, because that will do all sorts. Well, it just won't work. All right, so you've got to block the RF. You want the HT to get through from the power supply to the anode of the valve, but you don't want your 100 watts of radio signal going back to the power supply. So there's the RF choke. Lets DC through, but it won't let RF through. The capacitor you see there, where that goes off to the right, that goes to the aerial. Well, it actually goes through an Ariel Matching unit, but I haven't drawn that in, it'll complicate it. That goes off to the aerial. You want the RF from the anode of the valve, you want your radio signal, 100 watts, to go to the aerial, but you don't want DC. You don't want 3,000 volts on your aerial. That's not a good idea. So put a capacitor in there. That blocks the DC. HT can't get through the capacitor. RF can. So all you get to the aerial is RF, your actual radio signal. So you can see a combination of an RF choke, which will block RF signals, and a capacitor, which short out RF signals. I mean, I'm putting this very basically. I don't want to go into sort of in-depth mathematics. Well, mainly because I don't understand it. No, but we don't want to get bogged down with too much complicated stuff like that. Basically, the RF choke, anything coming up the mains in the form of a radio station or a lot of other interference is blocked by the RF choke, but the mains is let through. The capacitor shorts out any RF interference, whereas it doesn't short out the mains, which wouldn't be a good idea. Sorry for the quality of my drawing there for the transmitter, the PA stage. I still haven't got my proper computer drawing program, but there we are, scribbled in felt tip is good enough. Now, let's talk about another type of interference. We talked about the mains acting as an aerial and bringing the signal into your radio. Say you're tuned to, now as a good example, BBC, local BBC radio comes from Shoreham. There's a transmitter at Shoreham, so it's obviously a very good signal here because it's only a few miles away. My mains wiring acts as an aerial and brings that into the radio. So my radio is listening to the Shoreham transmitter not only via the aerial but via the mains. And the mains, 50 cycle mains, is modulating that signal with 50 cycle hum. That's what modulation hum is. So I'm listening to the station. It's only on strong stations, okay, and I'm getting a loud hum, quite a loud hum on the local BBC station. It's coming down the mains. This is the mains acting as an aerial. It's coming into the radio. The mains, the 50 cycle or 60 cycles, cycles, show my age, hertz, 60 hertz in America. Okay, that is modulating the radio station signal that's also coming down the mains into your radio. So the radio is humming. And this, you will notice, it only hums on perhaps one or two strong stations. You can tune around, other stations are fine. There's no hum. Between radio stations where there's just a bit of background noise, there's no hum. It's only on possibly one, in my case, or perhaps two radio stations, you get this very annoying hum. So that's what we're trying to get rid of, modulation hum, by blocking the RF, blocking the radio signals coming down the mains. Right, there's another type of interference. Vacuum cleaners, electric drills, and in the early days even hair dryers used carbon brush motors. Okay, carbon brushes, especially when the appliance is wearing out, the carbon brushes are wearing down, they arc on the commutator. And I've seen actually sparks travelling all the way around the comm, and you've got bzzz, it's like a firework display when it's really bad. All that interference from the appliance, say it's a vacuum cleaner, that is sent down the mains cable into all the house wiring. Okay, so wherever it's all coming out of the house, every socket you plug anything into is full of interference. Now, I've said that your house wiring can act as an aerial and pick up radio stations, causing the modulation hum. It can also radiate interference. Now, the interference from a noisy motor, a carbon brush type motor like a vacuum cleaner, that goes down the mains into all the house wiring in the loft and wherever, and that is transmitted. The house wiring again is acting like an aerial, but this time not for receiving, for transmitting. Okay, so take a transistor radio. Where's mine? Over there. Okay, it's not connected to the mains. It's only got its little aerial. We can walk round. If you've got a really noisy motor causing a lot of arcing and interference, wherever you go with your radio, if you go near a socket, an outlet or any of the wiring, you'll hear it. Brrr, dreadful interference. That is because the house wiring is transmitting that interference. So again, it's airborne. That is coming down your aerial. Okay, so how do you stop that? You've got it coming down the aerial and the mains. You can't stop RF interference coming down the aerial, because if you do that, you're also, if you block that with an RF choke, for example, you're also blocking your radio stations. That's not a good idea, because you won't hear anything. Okay, you won't hear the interference, but you won't hear any radio stations either. Have a look at this. This is a Belling-Lee interference suppressor. Now, I got this from eBay recently, actually, for £5. How about that? What this does, if you've got a noisy appliance, such as electric drill or vacuum cleaner, you stick this in the mains lead, okay, very close to the vacuum cleaner or the drill, as close to it as is sort of practically possible. So any interference coming from the appliance is suppressed before it gets into your mains, into your house wiring. Okay, so it comes out of the appliance, hits this suppressor, and okay, it doesn't get rid of all of it, but it will suppress to quite an extent a lot of the interference that would otherwise get back into the house wiring and cause all sorts of problems. These were very popular, you know, back in the 40s and 50s. They were very popular. There were a lot of carbon brush type motors causing interference. They don't seem to so much these days. I think they've got suppressors fitted anyway to them, so it doesn't apply too much today. And also there aren't so many mains radios. In fact, there aren't many transistor radios around these days. I think people listen to the radio on the internet now. So there we are. So it doesn't apply. But that Belling-Lee suppressor, as I say, that stops the interference from going any further back into your wall socket and then all round the house wiring, which would then not only take it to your radio via your mains lead, but transmit it, and you'd pick it up with your aerial. Okay, so you're getting it from all places. So that's the idea of that suppressor. Stop it at the source. You may have noticed on the Belling-Lee box it says effective at TV frequencies and short and medium wave bands. Basically the capacitor in here and the inductors, it's a filter. The values of capacitors and inductors are worked out to suppress interference on certain frequencies. Now TV was on, you know, the old, this goes back to the old 405 line tellies, the black and white tellies. TV was on VHF. What was BBC? 56 megs or something, sound and vision on whatever. So this was designed specifically for TV on VHF and shortwave and medium wave. Other types of suppressors are designed to stop other types of interference on other frequencies. Now have a look at this. Okay, I'm not going to go into the sort of details of how ferrite rings work, what they do. You know, you can look that up on the internet. But here's one way. Have a look at this. Someone's wrapped wire round the ring in and out as many times as possible. Now that wire there could be your speaker cables on your hi-fi. What could happen is the speaker cables, as I've said before, any bit of wire can act as an aerial. The speaker cables, especially if they're quite lengthy, going around the room to your two speakers, they act as aerials. They will pick up RF. Now if you use a ferrite ring in each speaker cable, as I just showed you the picture, wrap the cable through and through and through, then plug it into the amp, any RF on that cable will be absorbed by that ferrite ring. I say absorbed, you know, again, basically, that's the way to put it, basically. Don't want to get into heavy stuff. Okay, so put one on each speaker cable and that should do the trick. In the few years ago, I was, being a radio amateur, I was transmitting on AM. There was an AM net, not single sideband as most of it is now. And my next door neighbour came round and he said, I can hear you on my hi-fi through the speakers, perfectly clear. Every word you're saying, perfectly clear. So I said, yes, sorry about that. So his speaker cables were acting as an aerial. Now my transmitter wasn't at fault, okay? But if anything, his amplifier's at fault, because it's picking up RF, the amplifier is detecting it as a radio would, and then the audio is going to the speakers. You can hear every word I'm saying. On single sideband he wouldn't have heard it clearly, he would have just heard sort of dreadful sound effect, but you know what SSB sounds like possibly. So ferrite rings are good for getting rid of RF on bits of wire, as you know, like look at this picture here. There's a computer cable. They've got the ferrite clamps. You can clamp them round any cable you like. You get different sizes, clamp it round, and that will get rid of a lot of the RF on the cable. Now let's move on to another type of interference. I think we all know what a nightmare computers can be for causing interference. On the back of your computer, you'll recognise this, the 3-pin, like a kettle socket, and these have it's got a rubber sleeve on it. These have a built-in filter, EMI filter, electromagnetic interference filter. Yeah, there's a picture of one. See, that's even a little circuit diagram of the filter on there. Now with these, what these are supposed to do is stop any interference coming out of the computer and going down the mains. As you know, your printer lead has got ferrite clamps around it. Very often the mouse lead and the keyboard lead have them, not always. And that's to stop all the interference going down the mains from the computer. If you go near a computer, say with a transistor radio, a portable radio, you will obviously hear a load of all sorts of interference. But the idea of these is to stop that going down the mains. What I want to do is stop interference coming from the mains into the radio. This is a chassis I'm going to start some work on. There's another problem. I've said capacitors are like a short circuit to RF, okay? So if you take a capacitor, you've got your aerial plugged in your radio. If you take a capacitor from the aerial wire to earth, you'll lose all your signals. You won't hear anything, or very little. That's not true of the electrolytic smoothing capacitors, the HT smoothing capacitors. They're not very good at passing RF. They're great for smoothing the HT supply, but they're not particularly good at decoupling, getting RF off the HT rail. Now, RF can get onto the HT rail in various ways. There's the IF frequency, the IF cans, they're all supplied with HT. There is decoupling, there are decoupling capacitors, but you can sometimes get problems on the HT rail with RF on it, which is the IF intermediate frequency is RF, although it's called IF, it's still RF. So what you can do, you'd think the big electrolytic capacitor would be great for shorting out RF, but it's not. So what you do is get something like a 0.01 or 0.047 microfarad, just take that from HT down to the chassis, stick it straight on the HT smoothing can if you want to, from the earth connection to one of the HT connections. So that just decouples any RF from the HT rail. So that's quite important. You put all these things together, and you might think, I won't have any interference of any form whatsoever, but you will. You never eliminate it 100%. So yeah, computer interference. Anything with a microprocessor. These days washing machines have. They're kind of computer controlled, aren't they? So you've got so many forms of interference, and as I say, what I'm trying to do in this video is stop it coming up the mains into the radio. You could even fit one of these in the radio, on the back of it or something. It can't do any harm, put it that way. And I've actually got coming from China a chassis mounted type interference suppressor. I'll show you that when it arrives. I was hoping it was going to arrive today, but it's getting a bit late now. But I will wait until it arrives so I can include it in this video. Now, with an earth chassis, a type of radio that's got a proper double wound mains transformer, not a live chassis one like this, with an earth chassis, you would think there's not going to be a lot of interference, because it's earthed. All the metalwork is earthed. You're not going to get interference that way. Have a think about this. Your earth wire, let's say this is earthed, okay, goes to your plug, the socket. The earth wire travels all around the house, all upstairs, around there and down there and around there, eventually to your cupboard, wherever your consumer unit is, and then eventually to a proper earth point, the actual earth, wherever that might be. That could be, 40 feet long from the actual chassis here all the way around, 50 or 60 feet long. If you think about it, upstairs, around there, downstairs, around there, 10, 20, 30 feet, 40, 50. You end up perhaps 60 feet. Okay, does that matter? As far as the electrical safety is concerned, no. Very low resistance wiring if it's wired properly. Very low resistance path to earth. Any problems, it'll blow your fuse. Brilliant. As a safety earth, which it's meant to be, perfect. So what's the problem? You may have heard of a grounded Marconi aerial. I'm a radio amateur and I've used one and they're very effective. What a grounded Marconi aerial is, you've got aerial horizontal going along like that. Say this is upstairs room in your house, this is where you're working, or the downstairs room, so it goes up there, right the way down your garden, your wire, nice and high up, down the far end, into the ground. The far end of your aerial is earthed, okay, a grounded Marconi aerial. You might say, well, how can that act as an aerial for transmitting and receiving when you've taken the far end of it to Earth? What is going on there? Aerials are in a field of their own. I'm not going to get into discussing aerials here because it's a totally different issue. But basically, the grounded Marconi is a good aerial. You look it up, grounded Marconi. You can read all about it. It'll be just sort of a waste of the video if I go on for hours about the grounded Marconi aerial. But what I'm saying is, so you imagine your aerial like that, the far end's earthed. So what is this earth connection then? It's a grounded Marconi aerial. If you see what I mean, in effect, that's what it is. You've got from your chassis, your 60 odd feet of wiring, or through your house and wherever, eventually down to earth. A proper earth in the ground. That, although it's a brilliant electrical safety earth, low resistance path and all that, as far as RF is concerned, it's not. It's an aerial, if you see what I mean. So, any interference around, this earth will pick up. Your chassis will be kind of swamped with interference, if you like. I mean, I'm exaggerating now. Your chassis is kind of blasting out interference everywhere. Of course your radio's picking it up because the radio's built on the chassis. How closer could you get? To make matters worse, connected to your grounded Marconi aerial is your washing machine earth, your dishwasher, your tumble dryer, your freezer, your fridge, everything that's earthed in the house with thermostats and motors going click click and whir whir, buzz buzz and whatever. It's all coming up your earth wire to your chassis. Now, word of warning, do not disconnect your earth connection from any equipment. If something's earthed, leave it earthed, alright? I've got to say this, I know you're not going to be daft enough to go cutting the earth off all your appliances. If something's earthed, it's designed to be earthed, leave it earthed. Don't go doing that. Now, there's something called an earth line inductor. What's that all about? Some of these filters I've been talking about have an inductor, a coil, in the actual earth connection. This one doesn't, only in the live and neutral capacitors down to earth. Okay, some introduce an inductor actually in the earth wire. Is that a good idea? No, I don't think that's a good idea. The earth, your house wiring earth, okay, there are regulations about the resistance of the path to earth and all that. If you go, even if it's only half an ohm you're adding in the earth wire, you're adding resistance to your earth path, which is not good. So don't go, again, a word of warning, don't go winding coils and stuff and putting it in the earth lead. You know, it sounds safe enough. You think, well, if it's a thick, heavy thing and it's only half an ohm or less than that, what's the problem? Don't do it. That's the answer there. But some of these do have an earth line inductor to stop, to stop the earth bringing up interference, acting like an aerial. Is to block RF, basically, as we have done. Remember about the live and neutral, the coils, the capacitors, stops RF coming into your radio. Well, you can also do that on your earth wire, stops RF coming into the radio from the earth wire. But I've got to say this again, don't play about with the earth connection at all on any equipment. Okay, and certainly not on your house wiring. Don't go taking the sockets off the wall and mucking around in there. Okay, let's say your earth wire isn't 60 feet long, it's only a few feet, 5 or 10 feet, and it's not acting as an aerial at all. That's fine. It's a perfectly good earth. No interference is going to come up there. It's not acting as an aerial. Right, there's another problem. If you live, as a friend of mine did some years ago, next to, say, an industrial estate, he lived next to one in Lancing, up the road. He had a good earth system, not the house earth. He made his own RF earth in the garden, lots of wires and stakes. Whenever he connected his earth to his amateur radio equipment, the general background noise level increased. You can watch, I've watched him do it, the S-meter increased the background noise. Where was all this coming from? All this interference from his earth system he spent days and days constructing. It was picking up the interference underground from the factories on the industrial estate. The earth is a pretty good conductor of interference as well as electricity. A friend of mine and I, decades ago, we had a 100-watt audio amplifier, and instead of the 2 wires going to a speaker, mono amplifier, we took the 2 wires to 2 big metal plates, aluminium plates, we buried in the ground. Now, we didn't do this properly, we didn't really know what we were doing. There was no sort of impedance matching or anything like that. And we had another amplifier, okay, with a couple of metal plates that we took to the input. So you're listening, if you like, you're listening to the ground through the speaker of the other amp. And on the 100-watt amp, microphone 1, 2, 3, 1, 2, 3, the amplifier a few feet away with its metal plates in the ground, you could hear it. We were transmitting audio through the ground in the form of electrical waves, not sound waves. We transmitted audio through the ground. Had we done it properly, we might have got more than just a few feet, but I don't know, we read it somewhere, some magazine, some Practical Wireless or whatever, and we actually did it. So the ground, it will conduct all sorts of things, including interference. So there we are. I think that about sums it up, doesn't it? Is there anything else? I know people say, oh, you haven't mentioned this, you didn't mention that, and what about this? And if you get your calculator and do your maths, blah, 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 you'll find that the impedance and the reactance and all this, I don't want to get into all that, okay? I'm basically talking about, let's try and sort out interference on our radios. All right, let's not get involved with reactance and all this stuff. It just bogs people down. So is there anything else? I have to have a think. I'll have a coffee. That's a good idea. Right, I think that is the end of the video now. I've got to put this back together. This one's finished. Yeah, what was I going to say? All this interference business, obviously it won't apply to everyone. You might be thinking, what's he talking about? I haven't got any interference at all. So, it's not going to apply to everyone. But there is, it's just to let people know that you can get interference from all sorts of places that you wouldn't think so. As I've said, for example, the earth wire. Also metalwork. Here's a good example. I put up an aerial, my amateur radio aerial. One end of the garden had a 30-foot as aluminium pole, well, made out of a couple of poles, 30 feet high, which was to support one end of the aerial with an insulator, one end of the wire. Now the pole was insulated from the ground. I put it on a huge porcelain insulator. And I had some interference, and it was not bad, but it was definitely interference there. What I did was, just out of interest, I earthed the pole, and the interference level dropped considerably. vertical aerials, it seems, are more susceptible to interference. I mean, interference must be, they reckon it's transmitted in the vertical plane more than the horizontal. How true that is, I don't know. So a vertical aerial will pick up more interference. That's the kind of general consensus. So earthing the pole did cut down the interference on the aerial. The pole was picking up interference and re-radiating it. This is the thing about metal. You get a metal structure, it can pick up interference or whatever and retransmit it. It re-radiates it. So that's quite an interesting point. Try earthing things if you've got interference. You've got like I earthed, did have a metal greenhouse, metal frame greenhouse. Just out of interest, I earthed that. It didn't make much difference, but I thought, well, let's earth it anyway. That eliminates that. So there we are, that's that. My suppressor from China hasn't arrived. My coffee has. So yeah, not to worry about that. I was just going to show you what it was. As I say, it's a chassis mount thing. But right, I've got to get on. I've got to clean this back up. Get this has all been completely restored. Get this back together. And I've got to get on with some work. So thanks for watching. Hope it's been interesting. As I say, don't all get back to me with reactants and all this stuff. So anyway, see you in the next video. Bye bye for now.